So how do we do this without sharding? Um, Again, this kind of goes back to my background at Qualcomm, working with mobile operating systems um, and mobile networks. The first thing that people ever thought of was using a global clock in the network to create a source of time, and then use time as means of coordination between a large number of nodes. So what we constructed is a cryptographic source of time called proof of history. Um, and this is a subtle but foundational component. It's not a consensus implementation. It literally introduces a virtual global clock in the network that is used as a means of coordinating all of the nodes in the network. And because we have the source of time, we can use the exact same optimization techniques that folks have been using in wireless networks, for probably 100 years at this point. Um, and once we have that, like everything else that we're doing in terms of raw TPS numbers or latency, these are engineering problems that the people have been working on since, for the last 20, 30 years. It's parallel processing, it's optimizing memory throughput, it's building databases that can be horizontally scaled. It's like using a virtual machine that has a high performance JIT, and being very efficient about bandwidth usage. Um, these are engineering problems, and these are all things that we worked on and optimized to actually get us to the 50,000 numbers that we're seeing in our open public network. So for us, like, it's also important to obviously be a blockchain for developers. Um, our approach there has been really to give developers something that they can't get anywhere else. One of our features is that we can run multiple virtual machines. So right now we support LLVM compatible languages like C, C++, Rust, but we also ported the Libra's Move virtual machine. That means that if you're planning on supporting Libra, you can build contracts for Libra using their Move VM, and you can also execute them on Solana. And in fact, our implementation was running about 4 times faster at the time than on Libra, which was like pretty cool for us to show off. So we're planning a EVM port as well. And what's interesting is you can even take something like a Zcash sapling virtual machine and run it in Solana as well. So if you need privacy or these more kind of chain specific features, you can port that code over and execute it inside our runtime. That's what it really means to have a multi-execution runtime. And even though it's a separate virtual machine, it's still executing in the exact same atomic state. It's executing side by side, and that state can be used and evaluated between all of these VMs.